Okay, and I'll start recording as well. Okay, I'm going to start. I can let people in as they come. So today we'll cover Babylonian. We'll start Babylonian mathematics. We've actually done quite a bit of it with the quadratic equation, and then hopefully you had the opportunity to watch the video, and that's sort of giving an overview to that. And I'm wondering if there's any questions about the Babylonians in general or things from the video. I wanted to give you a sense of the culture and just sort of point to you to where we're going with the mathematics. Okay. So just a question. So what to you, if I'm asking like let's imagine this is an essay question. What's the difference between Babylonian culture and from what you know and from Egyptian, the difference between Egyptian and Babylonian culture, and how might those differences affect the mathematics? And you can, if you want to volunteer something, you can do that, or you could try to answer on the chat. Like, think of one difference between them.
Can you repeat the question real quick?
Yeah, one difference between what I'm looking for is overall sort of the Babylonian, just from the introductions that you saw, what differences might there be in the cultures, and how might that affect the development of their mathematics? So it's a two-part question. And so I'm saying the first part, can you think of one difference in their cultures? So one thing about them that's different.
Maybe the goal of getting to a final answer and not necessarily caring as much how they got there, because they used like methods of solving something that they just knew worked, but they weren't necessarily taught like equations.
Okay. And I was thinking more about the culture and then the mathematics. So go from above, like, what about the culture is different, and how might that have affected the mathematics? And I don't mean the mathematical culture. I mean something about their history or something about the civilization that was really different than the Egyptians.
I mean, I want to imagine something having to do with how the Babylonians didn't last nearly as long as the Egyptians, but I'm not sure how that could be related to math.
Well, the cultures did. I mean, the cultures were like, by the Babylonian culture, I mean the cultures that were in that area. They started roughly around the same time, and the Greeks ended sort of the independence of the cultures around 300 BCE. So in terms of the length, they were around for the same amount of time. But what might have been different about the history, say? They were both around rivers, and that's a similarity. I think that's really important. But what I'm looking for a difference and how that might have affected mathematics.
The Babylonians brought in a lot of different cultures, which resulted in the base 60, because it brought in base 2, base 3, and base 10.
Well, yeah, I mean, certainly, the one of the things that I think is really different is that the Egyptians were more or less isolated, where the Babylonians were like at a crossroads between so many different civilizations. And there was what we call ancient Mesopotamia was really a combination of a lot of different cultures that sort of came into the area and then lasted for a while. Maybe this is what Daniel was saying. And then another culture came in and lasted for a while. And what we think of as the High Babylonian culture, didn't start till about 2000 BCE, and then that lasted the longest. But it just was a sort of a succession of different cultures coming in and invading and changing the culture. And that was one of the things I'm thinking about. And then how might that have affected mathematics? Bryce, you started to get to that. I think I might have interrupted. And again, we're speculating here. So we're just kind of like thinking about this aloud almost.
Their mathematics had a lot more outside influence as opposed to being developed like purely internally.
Yeah. Yeah, I mean, it seems like they came in, just as language sort of changes with each new culture. That's why, we're different than British English for a lot of reasons. Each time a culture comes in, they contribute something. And we don't know what those things were, so I say it's a speculation. But the Babylonian mathematics, we kind of speculate that there was a lot of different influences that came into it. And you mentioned one earlier, and it's my speculation, but that maybe the reason they had base 60 is because they were mixing up sort of the counting methods of different cultures, and 60 is one that would work for a number of them. So that's kind of what I'm thinking. That's kind of what I was thinking of, and that's a good working hypothesis. And I hope. I mean, my sense is that the Egyptian mathematics was interesting and strong, but I think the Babylonian mathematics, we know more about it because we have, they wrote. Another difference would be that they wrote on stone and not papyrus, or they wrote on clay, which gets hardened like stone. And so, we have like hundreds of thousands of artifacts from that time, thousands of which, or hundreds of which, have mathematics, where we have a really small handful from the Egyptians. So, so it's just, and this is a history course, and so one of the things to think about, and I'll ask questions like this when we get to homework, and which will be soon, and then other things, is that how does the history affect the mathematics? Like you can even apply that to our culture. Why is our mathematics, and how is it different from other cultures? And what about our culture? We talked a little bit about that last week in a different context. Makes it the way that it is. So anyway, and then we'll get to the Greeks, and you'll see other differences yet about how their culture is different and maybe how it affected their mathematics. So again, just something to think about. So I think the two big takeaways are that the Babylonian, what we call Babylonian, is just it's a mixture of a lot of different cultures. Egypt was more or less static, we think, and then that probably affected the mathematics. And that the Babylonians wrote on these stone tablets or clay tablets that got hardened in the sun, so they're like stone. And they still, they're still around, many of them. And there were some theft and trading and stolen tablets after the Iraqi wars, the Gulf Wars 1 and 2. Some of those were stolen and during that time of upheaval, and then got sold, and because I guess they're trying to be recovered. So anyway, just things to think about. So that's one of the things I want you to think about. In terms of what we're going to cover today and Thursday, we'll pretty much cover a lot of computational things that the Babylonians did, as well as one thing that may be pure mathematics, and then as well, we'll also, we've also talked about the quadratic equation, and that's a good introduction. So think about what you learned as we go on. What about what you learned with the quadratic? How does that relate to what we're talking about today? Okay. So what I want to start with is this fifth worksheet. And so in the handout section, there's a few things there. You'll see handout number 5 and handout number 6. And we'll get to both of those today. And then there's also a video. CG's project was some computations in base 60, and we'll look at those in a little bit as examples. So the first worksheet is Babylonian sort of computations 1. It's been out there for a while, so you might have looked at it. And I just wanted to go over some of the stuff in more detail. Let's kind of go through, we have several questions, and just go over some of the questions as well. So I'll give you time to get those or get worksheet number 5. And we also have a 6th worksheet, which we'll get to. Okay. And then.
So is this in handouts week 4?
Yeah.
Blackboard?
Yeah. So you go to Blackboard handouts week 4, that's where it'll be. You should see 2 handouts as well as a link to CG's presentation, which we'll look at for a little bit today. Okay. So one of the things that here, let me pin this so I can see it better. And I just, wanted to, I don't know if you can see that well enough. It looks kind of small. I'm gonna write it down, but you can refer to that. So I just want to review a little bit about number bases. And so I'm going to think about a 4-digit, just bases in general. And again, this is on the sheet, and it's just kind of a warm up or an introduction. You've seen number bases before, hopefully in computer science or maybe in some other course. And generally, we use, like if this is base n and we're using somewhere between 2 and 10, we're using familiar digits. So let's just assume that n is some number that's bigger than 2 and less than or equal to 10 for our number base. And so if I take any of these letters, then each of the digits, sorry, that should be our n, our base is between 2 and 10. So each of these digits, they're going to be less than or equal to 10, less than 10, but greater than or equal to 0. So we have whatever our base is, the number is going to be, let's use n there. The number is going to be, the digits are going to be less than n. So if we had like n is equal to 6, then we would have our digit choices would all be less than or equal to 6. 5 would be the biggest digit, and then 0 would be the smallest. So I'm just going to put random numbers in here. I'm going to use base 6, so I can't put a number bigger than 5 in here. Just like we can't put us in the tens in any of our places in base 10, we can't have a number bigger than 9. So if this is base 6, the way you interpret it is since there's no decimal or point, we imagine that the decimal starts here. So it would be, that number would be 3 times 6 to the 0. And then we would add it to the 5, which would be 5 times 6 to the 1, 4 times 6 to the 2, and then 3 times 6 to the 3. So the way we would write this number, 3 times 6 to the 3, 4 times 6 squared, 5 times 6 to the 1, and 3 times 6 to the 0. Okay. And then if we wanted to see what this number was base 10, well, we just add everything up. 6 cubed is 216, so that's going to be 648. 36 squared is 36. 4 times 36, I believe, is 144. 5 times 6 is 30, and then we get a 3. And so we would add all these numbers up. And base 10, and then we would get our number. I'm going to actually emphasize carry. We have a 5 here, and I put a 1 up here. Think about why I do that. Because you're going to have to think about how to do this when the bases are different. So that's going to give me 12. I get another carry of 1, and that's going to give me 8. So that's how I'd write the number base 10. And since we're so used to base 10 or maybe binary or maybe hexadecimal, it's very hard for us to imagine what this number equals. It's very easy for us to see what that number equals, base 10. Sorry, that 10 here is just to signify the base. Okay. And then if we have a decimal place, so for example, I'll stick with base 6, and I'll just make up a number, 4, 7 point, oops, I can't do 7. 4, 3.51 base 6. Again, this would be 1 over 6 squared. This would be 1 over 6 to the negative 1, or 1 over 6. This would be 3 times 6 to the 0. and the 4 would be 4 times 6 to the first. So again, 24 from here, 3 times 6 to the 0 would just be plain old 3. 5 over 6 would be 5 6. And then 1 over 36, 1 over 6 squared. Okay. And then whatever this equals, we would add it up. 27. Find a common base here. 30 over 36 plus 1 over 36. Multiplied 6 over 6. And so we would get 27 and 31/36. Sorry, that point shouldn't be there. So forget it. That's not supposed to be there. So just ignore it. Okay. Okay. So that's how you write a number base. And then I have on the sheet, I give a couple of examples. And then I give an example for base 60, and it's the same as base 6, except you're using 60. And we're going to go through some examples of that, so I'm not going to go over it in detail now. I will just talk a little bit about, well, I'll give you an example, just a short one, just to emphasize the differences. Since my base is 60, my digits are going to be greater than or equal to 0, but less than or equal to 60. And we use commas, I've mentioned before, commas to separate the places so we can distinguish them. And then a semicolon is like our decimal point. It's a sexagesimal point. And you could use, I think it would be okay to use as long as you indicate that you're doing a different base, a decimal point would be okay, but that's typically how it's written with a semicolon. So again, to convert this, I would go, okay, 33 times 60, sorry. Because that's the 60th place, plus 47 times 60 to the 0, plus 3 over 60, plus 2 over 60 squared. Okay. And then, 33 over 60. Somebody want to tell me what that is? You can type it out. I think it's 1980, if I do it in my head.
Yeah, that's right.
And then to turn into a common fraction, you would add these base 10 and you get 20, 27, I believe. That's going to be 63 3600s plus 2, so 65 3600s. Okay. Okay. So kind of the first thing you want to do is to be able to go back and forth between base numbers. So with that in mind, why don't you work on the first 3 on the worksheet? And I'm just going to let you work at your places. No, actually, I'm going to throw you into groups. Let's see how many of you there are. There's 13 of you, so we'll have 4 groups. So again, I'll let you work on that, and I'll come visit the groups, and you can see what questions you might have. Or I'll see what questions you might have.
The first 3, correct?
Yeah, the first 3.
Okay.
I'm sorry, I should just type that out because that way you have a record of it. Even though you can't, I'm not sure you can see it when you're in the groups. But I'll type it out to the groups.
Thank you.
Hi, Emma. For some reason, you're not joining yet. Same with you, Daniel.
Oh, sorry. I wasn't paying attention.
At least you're honest about that. Okay, seeing if you have any questions. I'm hoping it's basic. The only trick is a number 1. Because that's going to have a very finite expression. Okay, any questions? If not, I'm going to go and just check out the other groups.
I think that's fine.
Okie doke. You can always ping me if you need me.
Will do.
Just checking in to see how you're doing. If you have any questions.
We're just working on it individually right now.
So there's a trick in number 1 that has a finite expression, even though the 1 is infinitely repeating. So just think about that, and I'll discuss that with the class. But okay.
All right.
Okay. So just again, ping me if you need me. I'm going to go check out the other groups.
Okay.
Just checking in to see how you all are doing. Do you have any questions? There's a trick for number 1. It has a very finite expression, even though you can simplify it, even though it has an infinite digit. I mean, infinitely many repeating ones, you can simplify it to something very finite. But I'll just let you think about that. Just if you, I'm going to go check out the other groups. Just ping me if you have a question. Just sort of checking in to see how you're doing, and to point out that number 1, there's a slight trick to that. I want you to simplify that as much as you can, and it has a very finite expression.
Yeah, we're trying to work on it. I mean, we're thinking that you can display, kind of do that as a with just summation notation, and it looks like it converges onto something.
Yeah, and think about what point, if you had let's say 0.099999999 repeating forever, what that becomes.
Yeah.
Okay. So in other words,
okay.
Yeah, in other words, what is this equal to? I'll write it out on the whiteboard, then I'll let you do what you want.
Oh, I see. I see what you're saying.
What would happen there?
So it'd just be 0.1.
Yeah, and something similar with the maybe something similar is going on here. That's all I'm going to say. Okay. Yeah.
Okay.
Okay.
Thank you.
Yeah, I'll let you work for a bit. You can either ping me when you're done with the first three, or I'll just come in and check in a bit. If you have questions, okay?
Okay.
Hey, we all done?
We believe so, yes.
Okay. I think number 3, the room number 3 is done too, so I'm going to go check them out. Do you have any questions before I leave?
So we just wanted to confirm.
I'll let the class, I'm going to do that when we get back to the class. We're going to crowdsource the answers.
Okay, perfect.
Okay.
Sounds good.
Okay.
Bye-bye.
See ya.
Yep.
Hello, sir.
Hey.
We just have a question of
Sure.
for the example. Do you see my screen?
Yes.
So, did you? Is there a typo here? Like when?
Again, we haven't. Yeah. I fixed that. We haven't got to that yet. I was going to come back and so you've done all. You're done with the 3 problems.
We are doing the number 3 now. We just want to
Okay.
check the first 2 answer.
Yeah. Well, we're going to crowdsource the answers. I'll have you check them with the rest of the class when we get back.
All right. Yeah.
Okay. But I can, if you want to show me what you're working on, I can certainly like look at it if you want me to do that. But I want to check the numbers with everybody. That's a way to generate discussion.
All right.
He's working on the left-hand side of his screen. We're working on the problem too.
Okay. Oh, I see what you're doing over there. Yep.
We're just doing it,
Okay.
writing it out, kind of how the example has it. So
Yep. I got the wrong answer because I added an extra decimal place there, but you're doing it right.
okay.
Okay, good. Okay. Okie doke. I'll go check out the room. So you're good to keep working?
Yeah. Yeah, we're good.
Yeah. I'm just seeing how you all are doing. You still working? Are you all done or?
Nearly done, yeah.
Okay, good. I'm going to crowdsource the answers with the when you come back. Okay, but if you have questions, I can certainly look at what you're doing. Nope. Okay. So just kind of checking in to see where you are.
We finished with the first 3.
Okay, good. So we're going to crowdsource the answers when we come back.
Sounds good.
Okay.
Are we going to be doing the rest of these as well?
Yeah, if you want to start working on them, you can. I was going to show like the CG's presentation in a bit, but you can start working on
I might
them.
have already started working on them.
That's fine. I just wanted to get a sense of where you were. And then that example, I have no idea what I was thinking, but it's wrong after the first equal sign. And so I put the corrected version, I hope, on Blackboard.
Okay.
Okay. So you know me, you've seen me before. I don't know what I was thinking. I think I was mixing up 2 problems and cutting and pasting and just screwed it up.
Gotcha.
Yeah. Okay. Okay. So I'll let you know when we come back.
Okay.
Yeah. I'll give you a 30-second warning at least.
Hi, sir.
Just seeing where you are. I was going to bring everybody back pretty shortly. Just
All
want,
right.
any questions?
That one is confusing.
Okay, tell me what's confusing about it.
So the other half is like over 60, right?
I'm sorry. Yeah,
Like,
the 2 is over 60.
and then 23 over 60 square,
Right,
and then 8 over 60 to the power of 4.
right.
It's a very big number.
Yeah, it's a very small number.
It's a small number, sorry.
Yeah. So you could use your calculator and just like plug it in, type it into the URL line and you can get an answer.
Oh, yeah, true.
Yeah. If you want to do that. But yeah, just I'm more concerned about setting it up and not the computation. And then I loaded a correct version of this I don't know if you can see me wave my cursor, probably not, but of the example, there's a correct version up there. But okay. Okay. So again, I'll let you work on just a tiny bit longer, but just make, does that make sense about how to do it? It's just tedious to do it by hand.
Yeah.
Yeah. Okay. Okie doke. So I'm going to bring everybody back in a very short while. Okay.
Okay.
Okay, I think everybody's back. Yep. Okay. So what I wanted to do is crowdsource, and then if there's any questions about the computations, I did make a mistake in the example. I think I conflated 2 different problems, but I uploaded a correct version, which we can look at. I think you're going to, a couple of people were looking at it and they said, "Is that wrong?" And I said, "Yeah, but the first line is right." So what did you get for the first answer, for number 1? You can either say it out or you can send it in chat.
Was it a 214.5?
Mm-hmm. Yeah. Okay. And then the point, do people see why it was 0.5? Okay. Yeah. Because, I mean, sort of the shortcut is, here, if we look at 0 point, I'm gonna pin this just so I can see it. I'm gonna go to my document camera for a second. So if you look at this, remember, this is base 10, so that's the highest digit. That, each time when you start rounding, you're just gonna shift everything over this way. It's really an infinite sum and it becomes this. Oops. Everything else is a 0. So if you're in base 3, then you had this, it would round to this. And so likewise in base 2, there's a couple of ways to look at it. That would round to this. And one way to see that, I saw that some people did this. Remember, this is Math 70 is a prereq, or now Math 100. So we know that that's true. So if R is equal to 1/2, you plug this in and you get 2. But remember, we have to subtract. There's no 1 here, so we have to subtract the 1, and we subtract the 1/2. So you're just going to get 1/2. Okay, because this is really what we're looking at here is this. And so that's 1 over 1 minus r minus the k equals 0 term minus the k equal first term. There's other ways to do that. Okay. Okay. So how about the second one? And I did that wrong because I got my places mixed up. So what do you get for the second one? If you just want to push out what you got, that would be great for each group. Okay. And if we have a disagreement, we'll sort it out. Anybody disagree with that?
Nope.
Okay. Okay. Now, the third one's tedious because we get up to 1 over 60 to the 4th, right? I think there's 4 decimal places in that one, or 4 sexagesimal. So we get 8 over 60 to the 4th. And that's one reason I gave that table, so you could look at it. I don't expect you to do that by hand. I would just enter that URL into a, enter that number, into a URL, and we'll do the computation for you and round it to enough digits. So so it's really funny because on the left-hand side, you have an economy of structure. You can get a really big number without many places, but that means on the other side of the semicolon, on the right side, you very quickly get very small numbers. So, okay. So again, I don't know if anybody got an answer for that. If you do, you just want to type it out. And let's say to 3 decimal places. I don't want to go crazy here. Yeah, it looks like you're getting the same thing. Good. Okay. So what I wanted to do next, are there any questions on this stuff? It's just wanted you to get comfortable doing the base conversions. But what I want to do next is, I'm going to clear my screen first of all, so give me a second to do that. I'm going to share, and hopefully this will work. Otherwise, I'll have you do it. So I'm going to go to Blackboard. And then hopefully you're seeing the Blackboard screen. If you're not, let me know.
Now we're not. It's just showing your kind of tabs.
Okay, we'll do it again then. Okay. I don't know what I did wrong, but okay. So again, I'll go to Blackboard. You seeing it now? Good.
Yep,
Yeah.
see it.
Good. So CG she did addition and multiplication of some base 60 numbers, and so I'm going to go to her presentation, and you can view the rest of it. She did well. I'll show you what she did. It's easier to show than to say. Are you seeing this? Are you still in Blackboard?
We can see it.
Good. Okay. So let me. I want to get some of these. I want to get the pictures away. Okay. So I think I just had played this already. So she's gonna. I'll start it from the beginning. Okay. I'm gonna pause it. So if this gets feedback or anything, let me know. So she wants to add these numbers, and she first converted everything to base 10 to check it. And so I'm gonna skip all that and go directly to where she adds in base 60. And the issue is going to be carrying. So let's see.
660. And this will be the number that we hope to end up with when we begin our base 60 arithmetic.
Okay.
Before we begin with our base 60 addition.
Okay. So the number she has is the circled base 60. Okay. And is everybody hearing okay when I just hit pause? When I play it, you're getting the volume?
Yes.
Okay, good. Okay. So pick up with the addition.
I have already gone ahead and separated steps 1, 2, and 3 because we'll be doing 3 different addition operations. So to start, we'll do 19 plus 50, which results in 69. When 69 is divided by 60, we are left with 1 with a remainder of 9. And so with these numbers, we'll write down the 9 here and carry the 1, which will later be added to 32 plus 15. Our next operation, our result is 48 plus 1 that we carried results in 49. We will end up with 0.49 base 60, where we will write down the 49 and carry our 0. Our third and final operation will be 45 plus 17, which results in 62. And when divided by 60, we get 1 with a negative 2. So we write down the 2 here and carry a 1, which will be brought down here. And we are looking just like we did above.
Okay, did that make sense in terms of the carrying?
Yeah, makes sense.
Yeah, and carrying, it's like you're so used to it that when you have to do it in a different base, it can be like, what? But you know, the idea, she did it exactly probably how most people would do it. And if you have to submit something, it's not a bad way to do it. You're going through what your reasoning is. The other thing you could do is just add 19 plus 50, put the 9 here, and like she did, put that 1 on top. So you could do it in base 60 as well. You don't have to convert it to base 10 to do it, but I think in the beginning it can make it make sense. Okay. So and again, when you multiply, it's going to be more complicated because you got to convert back. I don't know how to do that and sort of naturally. I think you need to convert to base 10, as you'll see. So I'm going to go to the same point. If you want to go back over this, I would suggest you do at some point. And you know, she went over how she converted from the base 10, base 60 to base 10, back to base 60 as a check. Okay, so I'm gonna jump to about 9 minutes, and then that'll take us to where she starts multiplying. She did the same thing with the multiplication. I'll pause when we get there.
Just as we did above. Down the rest of our numbers here. This is what we'll be comparing to our base 60 multiplication at the end.
Okay. So she did the same thing. She multiplied it. She did it in base 10 as a way of checking it, and then got an answer. And then she's going to go through the computations. And just think about, I'll let her explain it, but think about how you would do it. Just, I'll give you like, a few seconds, maybe 15, 20 seconds to think about how you would set up the multiplication. And some of it, it's already on there, but you can just ignore that. She'll walk you through it. So again, think about how you might do that. Okay, I'll start it right now.
Now, to begin our next step, I have gone ahead and separated all 9 steps of the multiplication operations that will be taking place. So we'll go ahead and start right here, step 1, with 32 times 18, which results in 576. And when divided by 60, we are left with 9 with a remainder of 36. I'll go ahead and circle that. And so we will write down our 9 here. I'm sorry, we will write down our 36 here and carry our 9. That 9 will later be added to our next operation. Now with 18 times 9, this results in 162. But when we'll add our 9, I'm sure you can see a trend. And our result will be 171. Now when divided by 60, we get 2 with a remainder of 51. So our 51 down here, we'll carry our 2. We can go ahead and cross out that 9 since we will be using it again. And we'll move on to our third operation, which is 18 times 15. Results in 270. Now we'll go ahead and add our 2 from above. We've got 272 divided by 60 gives us 4 with a remainder of 32. Now carry our 4, which will come down right here.
Okay, I'm going to pause just for a second. Are there any questions? And do you understand the carrying operation? And again, I think doing this when you haven't done this before, it's counterintuitive because you're so used to how you do it in base 10. This forces you to think about what you're actually doing. I think anytime somebody does this the first time, it's challenging. So I just was wondering if it made sense how she's carrying, if you had any questions about it. And I don't know how else to do this than use the base 10 intermediary step. And I don't know, I wonder, like, did Babylonians just know that that number is going to be 936? Or did they do some kind of conversion? Because it seems hard, you know? So I wonder about that. Okay. And then don't worry about the second and third line. I don't know. I'm guessing it was just when she filmed it, something happened and she wasn't able to undo it. Okay, I'll let her continue since there's no questions.
We'll continue with the same process as we did above for steps 4 through 9. And once all of our numbers there, I will pick back up with you. Now that we have completed all of our multiplication and all of our numbers are here, we will go ahead and add 36 plus.
Okay, before she does any adding, any questions about the steps? What she did is did all the work, and then now she's gonna, she filled it in there just like she did the first row. But any questions about what she did in those steps, we can just go back and look at them. So I'll step back just a little bit.
with the same process as we did above.
I just want to get them all on the screen.
Right here. We'll continue with the same process as we did above for steps 4 through 9.
Okay. Oh, sorry. That's good. Yeah. So any questions about it, what she was doing with any of those computations? Okay, I'll continue.
And once all of our numbers there, I will pick back up with you. Now that we have completed all of our multiplication and all of our numbers are here, we will go ahead and add 36 plus 0 plus 0, which gives us 36, 51 plus 4, which gives us 55, 32 plus 19 plus 48, which gives us 99, and we'll divide 99 by 60, which gives us 1 with a remainder of 39. So we'll go ahead and put our 39 here and carry our 1, and we'll add 4, 30, 48, and the 1 that we carried, and we'll get 83, which will divide by 60, which will give us 1 again with a remainder of 23. So write our 23 and carry our 1, 4 plus 1, which gives us 4, and write down our 6. And it looks like our answers here match up, and we're done.
Okay, I can go back if there's questions. Here, let me just go back a couple seconds so you can look at it. Any questions about that? Again, it's like you got to think about it, you know, and and I'll give you a chance in a minute to work on it. So I'm not sure we'll finish all of this today, and that's okay. But I'll stop this and bring you back. But I just want to make sure there's no questions. So I just have one for you. What are we multiplying that 6 by? What power of 60? So we got 6, 4, 23, et cetera. So what that leading 6, what power of 60 is that?
Is it 5?
Yeah, 60 to the 5th. And I don't even have that on my chart. So we're going to go about 720 million, I think. Just doing it in my head, maybe a little more than that, but that's just roughly. So we're almost up to 1 billion with the 5th place. So again, it's very efficient, right? Very big numbers, very quickly. Oh, okay, so I'm going to go back. I'll stop the share. And then I'm going to write down what I'd like you to do for the remainder. I think I would like you to do 6 and 7. And I'll just send you back to the groups. And number 6 is you want to convert from base 10 to base 60. What's your procedure? How are you going to, like, I'll just start you here. 2156. And I'm writing some numbers over here. And remember, this is 1, 0. This is 1, 0, 0, and 1, 0, 0, 0. So what's going to be, how are you going to convert that 2156? Are you going to divide it by 3600, by 60? Is it going to be a 2-digit number, a 3-digit, 4-digit?
Two-digit number?
Yeah, it's going to be 2-digit because it's between these two numbers. It fits in here. That's why I gave you that chart. And so it's going to be between this number and this number. So that means it's more than 60, less than 3,600. So you'll divide by 60. Okay. Now let's say I gave you this number. How many digits will it be in how many sexagesimal digits here?
3.
Yeah, it's 3. It's going to fit in here anywhere. So you'd start by dividing it by that. So you would divide it by this. Let's put a 2 here. We're going to get 7,200. That's not going to be enough. I'll start here. Yeah, I will. I'm going to start here. So if I do, I got to start here. Sorry. So 7,200, and then I bring down 6,756, and then I'll get a 1 here. So 3,600. My remainder is 651. So I would know that this digit would go in the third place, and then I'd fit 156. That's going to be, now I divide by 60, and I would get 120 plus 46. Sorry, you can't see that. So I'd put a 2 here and a 46 here. So again, it's sort of an iterative process or recursive process, I guess, is you figure out where it belongs, and then you divide by the power of 60 that's the greatest, power of 60 that's less. So it's like a floor function. Does that make sense? Yep. Okay. So that would be for number 6 and 7. I'm just trying to decide. We only have like 5 minutes left. So why don't you just do number 6, and you can stay here and do it rather than go to your groups. No, actually, I'm going to send you to the groups because it doesn't take that long, and that way it's easier to talk to people. So again, just do number 6. If you get that done really quickly, start 7. I don't want to keep you late. Just want you to think about that multiplication. Okay, questions, and we're not going to have time to crowdsource, so I'll be happy to tell you what I got.
I'm still working on it, so I don't know if you
Okay,
want to say
yeah.
the answer. It's
Yeah. So how are you starting? 2156. What do you divide by to start?
60.
Yeah. And did you get a number for that?
It's 35.9333.
Well, yeah, but what's the whole number?
35.
I got 34. But I could be me as, let's see. I got 2156 minus, oh, I see what I did wrong. No, wait. Yeah. I think I see what I did wrong. I did. I just made a mistake. Yeah, 35 looks right. Yeah.
Okay, and then, so from that, so I subtracted 60 times 35 from 2,156, which gives you 56.
Right.
So.
So you should get 3556.
Mm-hmm.
Okay.
Yep.
Okay. Yep. Good. Okay, I'll let you work on the other one.
Okay.
Yep. And you can, yeah. Okay. Good. I won't waste too much of your time since there's not much class left, but if you've got, I can check the, tell you what I got, if you're working on them, or if you, okay. So I got 3556 for the first one. Good. Okay. And then for the second one, again, my numbers should always be double checked. I got 1, 1, 1556. And I started off by dividing by 216,000. Does that make sense? Good. Okay, good. I'll let you work on that, and I'll come. I just want to check everybody briefly. Okay. Okay. Questions? And I've got answers, so we don't have time to crowdsource, so I can share those with you.
Oh, I'm done. So,
Okay.
for 6, I got 35,56.
Yeah.
And 12, 51, 55, 52.
Okay. Did I do that? Oh, did I do that wrong? Okay. So when I did it, I wonder if I made a mistake.
Or that I just made a mistake.
Okay, because my remainder upon the first division, oh, sorry, I see what I did wrong. So what did you get again?
12, 51, 55, 52.
Okay, I think you're right. I see what I did wrong. I was off by a place. Okay, it's tricky, right?
Yeah.
Yeah.
Oh, the tricky one was 7. Oh my gosh.
Yeah.
Just because I have an answer for that.
So what was your general approach with the semicolons?
So what I did is I just wrote out all the, like, because I just did 23. I did 23 times 18, or like with the appropriate 60 powers, and then I just wrote out all the like resulting multiplications and added them up together.
Yeah.
And I wrote them down in base 60, and then I added them together.
Yeah, and then did you put the decimal places in at ignore them, then put them in?
No, I had the decimal places.
Oh, you did. That's what I do. I just ignore them, and I know that I have 3. So I figured out how that's going to factor into my answer should have 3. So just, but anyway, I'm going to, since it's time to go, I'm going to go back to in the class, but yeah. Okay.
Oh, wait, I didn't actually say I got 7, 11, 24, semicolon, 19, 2, 40.
Yeah, I'm off by 2. I remember that, and I forgot to correct the answer. So I got 11. You're right. Yeah.
Okay.
Okay.
Sounds good.
Okay.
Thank you.
Yep. I'm going to bring everybody back. or let them go, or you can just take off if you want. Okay.
Have a good day.
Yep. I'm just bringing everybody back to say goodbye if you haven't left already. If you want answers for number 6, I will just I'll put them in the chat, and then if you don't, you can we can pick this up tomorrow. So here's what I got.
Did everyone just left?
Yeah, I think it's because it's after 6:15.
Oh, okay. I didn't see a time at all. I was like, where's everyone?
That's what I got. Those 2 things.
Yeah, I'm trying to figure out the second one, and I somehow got it wrong. So
I can go over that with you if you want.
no, I'm looking at your answer right now, so I'll just check.
And I got it wrong. This is what somebody got, and I think they got it right. I made a mistake, and that's why I'm pretty sure that's the answer.
Oh, I made a mistake as well, and I got really close to it. So I was just like, is there something like some minor mistake that I just made myself, or what happened to the 30 behind when you divide them?
What happened to what?
The 30 behind 216.
Okay, here's what I did, and this I did it. I'll show you what I should have done. What I did wrong because I don't know, I just screwed up. So here's the number. Again, I'm going to do this by hand. You can use a calculator.
No, I'm doing it by hand as well.
Yeah. So if I multiply this by 10, wait, is that right? Is this the right number here?
No, that's not the right number. It's 27, not 22.
Okay. So if I multiply by 10, I can do that, right? Because if I multiply by 10, I get 2160000.
Uh-huh.
And then if I multiply by 11, so you have to kind of get it. So if you multiply by 11, I'm going to add 216 to this 000. So I get 000, 6, 7, 3, 2. And that's still not going to be enough. So I'm going to add another 216. Okay, that looks to be about it, right?
Oh, okay.
Now there's other ways to do this.
Yeah, because I just put 1
Right.
at the
Right.
at the final second digit.
Yeah, so what you probably need to do is get a calculator out and then multiply, keep multiplying by 216 until you get a number that's too big, and then back down 1.
Ah, I see.
Okay, so I do that, 6, 17 is 8. So that's what I should get for my remainder. And that's going to be too big now. So now for my remainder, I can do 3,600, and that's a little bit better. I know if I multiply by 20, I get 72,000, right?
Uh-huh.
So I have to keep playing with this to get the right number. And somebody, so I don't know. So I don't know what I would kind of play around with my calculator until I got a number that's same thing. Let's just see what happens if you do it the way that you did it. So we put a 2 here and we get 72,000.
Sir, I think you got it. You left for 1 on top as well, I think. Did you? Wait, no. Oh, wait. Oh, okay. Oh, that's weird.
Oh, I also wrote it wrong too. I got 86952. I transposed. 86.
Oh no, yeah, and then the first minus, you kind of got it wrong as well. There should be a 1 left. It's 2592000.
Oh, okay. So what should this number be right here?
That should be 186952.
This number, multiplying it by 12.
I can't see it, sir.
Okay.
Sorry.
No, that's all right. That's all right.
No, I think I got it. Yeah, I think I just did some silly minus mistake and end up not correcting the answer.
Like me, like I did. Yeah.
Yeah, it was just a too big number, and I didn't use calculator. That's why I just like using my brain.
Okay, but you got it figured out?
Yeah, I got it figured out.
Okay, good.
All right. Well, thank you, sir.
Okay, have a good evening.
You too.
Yeah.
Bye bye.
Bye bye.